Hi, my name is Rivers Andrews, and today I'm going to be teaching you all about significant figures. The first question you may have is, what are significant figures exactly? Significant figures are numbers that are considered useful or significant for chemistry. So that means they're numbers that would be counted in any equations that may occur. Why do we use significant figures? Why does it matter? Well, when making calculations, your answers are only as accurate as the least amount of figures within your calculations. This helps to eliminate any technical error. Now I'm sure you're wondering, what are the rules of significant figures? What exactly makes a figure significant? The first rule of significant figures is that all non-zero numbers are counted. That means any number from 1 through 9. For example, the number 3 has one significant figure. The number 31 has two significant figures, and the number 31.2 has three significant figures. This is because all of the numbers shown are not zeros. All captive zeros are counted. This means any zero that is sandwiched in between two non-zero numbers. For example, the number 301 has three significant figures. This is because the zero is sandwiched in between two non-zero numbers. The number 32.02 has four significant figures, because yet again the zero is sandwiched in between two non-zero numbers. The number 3.102 also has four significant figures. The next rule is that trailing zeros, or zeros that come after a non-zero number, only count if there is a decimal present. For example, the number 3,500 has two significant figures. This is due to the fact that there's no decimal after the two zeros. The number 30.0 has three significant figures because of the decimal in between the two zeros. The number 300 has one significant figure. This is because there's no decimal after the two zeros. The number 3.0 has two significant figures due to the decimal in between the 3 and the 0. The fourth and final rule is that all leading zeros do not count. This includes after a decimal as well. For example, the number 0.1 has one significant figure. This is because the leading zero before the decimal does not count. The number 0.01 has one significant figure as well. This is because the two leading zeros, the one before and after the decimal, do not count. The final rules that I will teach you are the rules for multiplying, dividing, and adding and subtracting. Your answer must have as many significant figures as the number in the problem with the fewest number of significant figures. For example, 3.1, which has two significant figures, times 3.21, which has three significant figures, times 1, when you plug it into the calculator, comes out as 9.951. This is not the correct answer, as you need to have one significant figure, as the number 1 in the equation only has 1, and it is the fewest number of significant figures. Thus, the answer 9.951 will be rounded up to 10. When doing equations that involve adding and subtracting, your answer must have as many places to the right of the decimal point as the number in the problem with the fewest number of places to the right of the decimal. For example, 2.1, which has two significant figures and one place to the right of the decimal, plus 2.33, which has three significant figures and two places to the right of the decimal, plus 2.1459, which has five significant figures and four places to the right of the decimal, should equal 6.5759 when entered into the calculator. However, this is not the right number, as it should have one place to the right of the decimal, as does the number with the fewest number of places to the right of the decimal. Thus, it should equal 6.5. Thank you for watching this video. I hope you enjoyed it. Please feel free to rewind this video and watch it as many times as needed to really make the ideas and concepts presented concrete. Thank you.